Imagine, for just a moment, a civilization so advanced they built their entire existence around a black hole. Not by accident, but by design. These beings, facing the end of the universe as we know it, dismantled planets, harvested asteroids, and constructed a shell around this black hole, a place where time itself bends and stretches. You see, black holes have this incredible ability to warp time due to their immense gravitational pull. In doing so, this civilization found a way to cheat time, to extend their final moments for what seems like an eternity. Ever wondered what it would feel like to live in a place where time doesn't quite behave like we're used to? Now, think about the sheer ingenuity required for such a feat. You'd need to harness the materials from entire star systems, break them down atom by atom, and reassemble them into something functional. A colossal engineering marvel that wraps around a force so powerful that even light can't escape it. If you've ever seen a construction project like a skyscraper or a dam, imagine multiplying that complexity by a billion. They didn't just build for today or tomorrow, but for the future they would witness at a different pace than the rest of the universe. Pretty wild, right? But here's the kicker: time is different near a black hole. Einstein taught us that gravity distorts time, meaning that while years, centuries, or even millennia might pass outside, this civilization would experience a slower progression of time, as if they were watching the universe burn out in slow motion. It's like hitting the pause button while everything else continues to race forward. And in this suspended state, they reflect on the nature of time, space, and existence itself. But there's more to this story than just time. It opens up questions that have fascinated humanity for centuries. You might wonder, why would anyone go to such lengths as dismantling entire planets? Well, in a universe spiraling toward its end, this civilization had no other choice. By breaking down these celestial bodies, they weren't just salvaging materials, they were buying themselves time, quite literally. Each asteroid and planet they took apart provided the raw materials needed to build an intricate structure around the black hole. You can think of it as the ultimate act of cosmic recycling. And here's where it gets fascinating. By living so close to this immense gravitational force, they experienced time more slowly than the rest of the universe. In a sense, they became spectators to the universe's demise. This slowing of time due to the black hole's gravity, something we call time dilation, is one of those mind-bending concepts that you've probably heard of but haven't fully wrapped your head around. It's like when you're watching a movie in slow motion, except in their case, the movie is the entire future of the universe. They get to observe cosmic events, like the slow cooling of stars or the quiet expansion of space, in a way that no other civilization could. Just imagine sitting there, watching everything unfold at a pace where a second feels like a century. It's the ultimate vantage point to witness the universe's fate. So, here they are, surrounded by this black hole, living in a world where time barely moves, contemplating their place in a universe that's on the brink of collapse. They might have looked out and wondered, is this really the end? As they witnessed galaxies fade and quasars disappear. But even in the face of such cosmic decay, they had hope that by bending time, they could delay the inevitable. Yet, this delicate balance raises a deeper question about the nature of time itself. Now, here's where Einstein comes into play. His theories of relativity changed everything we thought we knew about time and space. Imagine this: for centuries, people thought time was a constant, ticking away uniformly across the universe. But Einstein flipped that idea on its head, showing us that time and space are intertwined, bending and shifting depending on gravity and speed. Think about those astronauts floating out in space, where time moves just a little slower compared to life here on Earth. This civilization, sitting on the edge of a black hole, takes that concept to the extreme. Their version of time is drastically different from what we experience. This leads to bigger questions, ones that touch on what it means to exist in such a warped reality. If time isn't constant, then what does that mean for life itself? We often live our lives according to the clock, counting the hours and planning for the future, but what if the very fabric of time is as flexible as Einstein suggested? The idea that time stretches, contracts, and even warps in different environments forces us to rethink how we view everything. If you were in their position, living in a place where time barely moves, how would that change the way you live your life? Would you rush through things, or would you take each moment as a gift? Einstein's ideas weren't just about equations on a blackboard, they have real implications. This civilization's survival strategy taps directly into that. By positioning themselves near a black hole, they're playing with the boundaries of time, using the laws of physics to stretch their existence far beyond what would normally be possible. And in doing so, they force us to ask the age-old question, what is time, really? But as we explore this question, another layer unfolds. What about those who laid the groundwork before Einstein, like Galileo and Newton? It's fascinating to think how different our understanding of the universe would be without the contributions of people like Galileo, Newton, and Leibniz. Galileo, for instance, was one of the first to turn his telescope to the heavens and begin charting the movements of celestial bodies. In doing so, he paved the way for Newton's laws of motion, which are still fundamental to how we perceive the physical world today. Newton's genius lay in connecting the dots between the movement of the planets and everyday objects, something that revolutionized science. It's like realizing that the same force that pulls an apple to the ground is also what holds the moon in orbit. If you ever want to see their legacy in action, just look at how modern engineers design spacecrafts, ensuring they follow Newton's principles to reach their destinations. Then comes Leibniz, who wasn't just a philosopher but also a mathematician whose work on calculus opened new doors to understanding motion and change. His rivalry with Newton might have been intense, but their collective insights shaped centuries of scientific progress. While we often think of these figures in isolation, their ideas built on each other. They took what seemed impossible, understanding how things move through space and time, and made it part of human knowledge. The interplay of their theories shaped everything from the way we build bridges to how we explore the furthest reaches of the cosmos. You can almost picture them sitting around a table, comparing notes, each contributing a piece to the puzzle of time and space. And then, Einstein enters the scene, taking all that came before and expanding it to the cosmic scale. He didn't just build on Newton's ideas, he transformed them. While Newton gave us gravity as a force, Einstein gave us gravity as a warping of spacetime itself. It's as though he said, wait, there's more, and opened up a whole new realm of possibilities. These historical figures weren't just scientists, they were dreamers who dared to question reality itself. But even with all their progress, the universe holds deeper secrets, like entropy and the concept of its eventual heat death. Entropy is a sneaky concept, it's all about disorder, and it's everywhere. You've probably noticed how things naturally fall apart over time, right? That's entropy at work. It's the reason why your cup of coffee cools down or why your room gets messy unless you put in the effort to clean it. The universe is no different. Over time, it's slowly marching toward greater disorder, toward something scientists call heat death. In this grim-sounding future, everything reaches a state where no energy is available to do any work. In other words, the universe becomes cold, dark, and lifeless. Now, imagine that civilization we've been talking about. How do they face the idea that, no matter what they do, everything eventually falls into chaos? This is where things get really interesting. Even though they've managed to manipulate time near a black hole, they can't stop entropy. It's an inevitable force, one that even the most advanced technology can't overcome. It makes you wonder, when the universe reaches this final state of heat death, does time still matter? Without change, without motion, what is time? It's like having a clock in a room where nothing happens. The hands might keep ticking, but does it really mean anything? This civilization might be able to stretch time for themselves, but they're still bound by this universal law. It's a reminder that, no matter how far we push the boundaries of science, we're still part of a larger, unyielding system. The concept of entropy isn't just theoretical either. We see it play out in everyday life, from the way energy is used up in our devices to the gradual aging of our bodies. And while we can't stop it, we can slow it down or work with it, just like that distant civilization. Yet, as they ponder the meaning of time in a universe destined for heat death, they start asking bigger questions. If everything is heading toward a cold, static end, can we still find purpose in that journey? And that's where Einstein's theories start to dovetail into even more mind-bending ideas, like time travel and bending reality. Einstein didn't just stop at explaining gravity and time. His theories, both special and general relativity, opened up possibilities that sound like they belong in a science fiction movie. Special relativity deals with the idea that time isn't the same for everyone, it changes depending on how fast you're moving. You've probably heard of the twin paradox, where one twin travels through space at near the speed of light and returns younger than the other. Wild, right? But it's not just theoretical. Time dilation has been proven with clocks on satellites, which tick slightly slower than clocks on Earth. This is the foundation for ideas like time travel. Moving fast enough or being near something as extreme as a black hole could alter how you experience time. Then there's general relativity, which brings in the effects of gravity, suggesting that the very fabric of space and time can be bent. If you can bend space, why not connect two distant points through a shortcut, a wormhole? This is where the real fun begins. In theory, wormholes could allow for faster-than-light travel or even time travel. Imagine stepping through one end and popping out the other in a different time or place. Sounds like something out of a Star Trek episode, but scientists are genuinely considering these possibilities, though we're a long way from proving it. Just imagine if that distant civilization found a way to use such a shortcut to escape the inevitable death of the universe. The idea of rotating universes also plays a role in these discussions. Some theoretical models suggest that, if the universe or parts of it were to rotate, it could create closed time-like curves. This essentially means time loops, where you could return to a previous point in time. Of course, the practical challenges of creating or accessing these are monumental, but they open up questions about what is truly possible. What if this civilization managed to find one of these cosmic loopholes? Could they escape the universe's fate, or would they be trapped in an endless cycle of time? These ideas naturally lead us to deeper philosophical questions about the essence of reality. As fascinating as these scientific breakthroughs are, they ultimately bring us face to face with deeper, more philosophical questions. What is reality, really? If time and space are as flexible as Einstein suggests, does that mean our very experience of existence is subjective? Think about it. If time can stretch and bend, and if space itself can warp around us, then the reality we perceive might not be as solid as we once believed. It's like looking at a reflection in a funhouse mirror. It's still you, but everything is distorted, and you can't quite trust what you're seeing. This civilization, perched on the edge of a black hole, must grapple with these questions daily, living in a reality that is fundamentally different from ours. The truth is, for all the advances we've made, there's a good chance we'll never fully grasp the true nature of time and space. Sure, we've got theories that explain how things work on the grand cosmic scale or down at the quantum level, but every new discovery seems to open up more mysteries. It's like pulling on a thread that never ends. This distant civilization might have mastered the mechanics of living near a black hole, but do they really understand the nature of their existence any more than we do? Maybe the more you learn, the more you realize how little you know. That's both humbling and awe-inspiring, don't you think? And that's where we're left, with more questions than answers. What is reality? What does time mean when the universe is spiraling toward its inevitable end? These are questions humanity has pondered for centuries, and while science has given us incredible insights, the ultimate truths may remain just out of reach. Maybe, like that civilization, we're meant to live in the mystery, always reaching but never fully grasping. And yet, the quest for understanding never stops, it pushes us forward, even when the answers seem to slip through our fingers. So, after all this talk about space, time, and reality, what do you do with it? Sure, it's fascinating to think about black holes, time travel, and the universe's inevitable end, but how does that change your life right now? Well, here's the thing, understanding how small we are in the grand scheme of things can be both humbling and empowering. It gives you perspective. What will you do with the time you have, knowing that even civilizations near black holes can't escape the laws of entropy? Maybe it's time to focus on what really matters in your life, knowing that every moment is precious because it's fleeting. But don't stop there. Challenge what you think you know. The universe is full of mysteries, and science is just one way to explore them. Maybe the next big breakthrough in understanding reality will come from a question you ask. After all, every great discovery started with someone wondering, what if? So, why not start asking those big questions yourself? How does time shape your life? How do you make sense of a world that's constantly changing? If you want to keep diving into these big ideas and learn more about the mysteries of space, time, and everything in between, make sure to subscribe to the channel. Hit that notification bell so you never miss a video. We've got so much more to explore together. The journey into the unknown has just begun, and you won't want to miss what's next.